And let's take a look at models involving rational equations. And basically these are formulas. So we're solving, try it again, solving formulas for a variable. Our first step is to get rid of parentheses. Our second step is to get rid of fractions. Our third step is to get everything with the variable we're solving for on one side, everything else on the other side. So get everything with the variable we're solving for on one side, everything else on the other side. Step 4. If the variable we are solving for is in two or more terms, factor it out. So if the variable we're solving for is in two or more terms, factor it out. And then our last step, divide both sides by what is in front of slash back of the variable we're solving for. So divide both sides by what is in front of slash back of the variable we're solving for. Well, let's take a look at our first problem. Now these follow the rational equations because the rational equations, well, they're in a chapter dealing with rational expressions, but they follow rational equations because rational means single fraction, and then when you're talking about rational expressions, you have variables in it, which is what we have here. So we have fractions with variables in them. Okay, so we got x minus y over p equals z over m, and we're solving for p. Our first step is get rid of parentheses. We don't have any. Second step is get rid of fractions. Well, we need to figure out what our LCM is. Now, we have m and p, so our LCM will be mp of the denominators. And that's what we're going to multiply everything by. So we'll multiply by x minus y over p equals mp times z over m. It's always the same way. To get rid of any fraction, anytime we've been solving equations, we always multiply by the LCM of all our denominators. And these are even easier because if you have a single letter here, single letter here, then you just multiply them together. P's cancel and the m's cancel. And we're left with m times x minus y equals pz. Well, distributive property, m times x is mx, minus m times y is my, equals pz. Third step, get everything with the variable we're solving for on one side, everything else on the other side. We're solving for p, so everything with a p is on the right side and everything else is on the left side. So that's already done. Step 4, the variable we're solving for is in 2 or more terms, factored out. Terms are separated by pluses and minuses. This is just in one term, so we don't have to do step 4. Step 5, divide both sides by what is in front of / back of the variable we're solving for. We're solving for p. There's nothing in front of it, but there's a z after it. So we'll divide both sides by z. So we got mx minus my over z equals pz over z. These z's will cancel. And we got p is equal to mx minus my all over z. And that's our answer. Let's take a look at our second example. Okay, so we got a is equal to b over c minus d, and we're solving for d. So we want to have d equals something when we're done. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. Well, we only have one denominator, so that is our LCM. So we'll multiply both sides by c minus d. So we'll multiply the a by it, and we'll multiply this fraction by it. When we do that, these c minus d's cancel. And over here we got a times c is ac, a times negative d is negative ad, equals b. Okay, step 3. Get everything with the variable we're solving for on one side, everything else on the other side. We're solving for d as in David, so I'm going to take this negative ad to the right side, and I'll take this b to the left side. Remember, when you take anything across your equals, your sign changes. So I got ac minus b equals ad. Fourth step, if the variable you're solving for is in 2 or more terms, factor it out. Well, this is only in one term. Terms are separated by pluses and minuses. Last step, divide both sides by what is in front of / back of the variable you're solving for. We're solving for d. There's an a in front of it, so we'll divide both sides by a. So we got ac minus b over a is equal to ad over a. These a's cancel. Now over here, these a's don't cancel because we've got a minus in here. Everything has to be multiplication for you to be able to cancel them. Now formulas are always a area that students struggle with. A lot of it is you look in the back of the book and your answer may not match. You've done it exactly right, but you look in the back and it just isn't the same. Depending upon how you solve this problem using shortcuts and so forth, you can come up with different answers. I could actually even go further here. Notice the minus here. We can split this into 2 separate fractions. So you have ac over a minus b over a equals d. And then these a's would cancel, and you'd have c minus b over a is equal to d. So on these formula problems where you're solving for a variable, if you don't get the same answer as the back, don't really stress about it, because that oftentimes happens. Let's take a look at the next one. Let's see, we got a is equal to 2b minus 5c over d minus e, and we're solving that for e. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, the d minus e, so that is our LCM. So multiply both sides by that. So multiply the a by it, and we'll multiply this fraction by it. The d minus e cancels here. A times d is ad. A times negative e is negative ae, equals 2b minus 5c. Okay, third step. Get everything with the variable we're solving for on one side, everything else on the other side. We're solving for e, so I'm going to get everything with an e on one side and everything else on the other side. So I'm going to take the negative ae to the right side, and I'll take the 2b minus 5c over to the left side. Remember, you take anything across your equals, your sign changes. So the 2b becomes a negative 2b, the negative 5c becomes a positive 5c, and the negative ae becomes a positive ae. It actually doesn't matter which side you take things to. I did it that way so that the negative ae would become positive. Step 4. If the variable you're solving for is in two or more terms, factor it out. Solving for e, it's only in one term. So we still don't have to do that step. Step 5. Divide both sides by what's in front of / back of the variable you're solving for. There's an a in front of the e, so we're going to divide both sides by a. Now when we do that on the right side, those a's are going to cancel. And we've got e is equal to AD minus 2b plus 5c all over a. And that's our answer. Let me start a new page. And let's look at our next problem. Got a is equal to BCD. These are meaningless formulas, by the way. I just made up ones. The same techniques though you see in solving these will be ones you'll use on actual formulas. Ones you might see in chemistry or physics. And we're solving this for E. Okay. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. I only have one fraction, I only have one denominator. So e plus f squared g squared is my LCM. And that's what I multiply both sides by. So multiply it by the a. And we'll also multiply times the fraction. When we do that, this e plus f squared g squared cancels with this. Over here we got a times e is ae, and a times f squared g squared is a f squared g squared equals bcd minus 5. Step 3. Get everything with the variable you're solving for on one side, everything else on the other side. We're solving for e. So I'm going to take this a f squared g squared to the right side. So we've got ae is equal to bcd minus 5 minus a f squared g squared. Step 4, if the variable you're solving for is in two or more terms, factor it out. Well, terms are separated by pluses and minuses, so this is just one term. Step 5. Divide both sides by what's in front of / back of the variable you're solving for. We're solving for e, there's an a in front of it. So we'll divide both sides by a. There we go. I'm going to do that. Those a's are going to cancel. And we got e is equal to bcd minus 5 minus a f squared g squared all over a. And that's our answer. Let's look at our last problem here. Got a is equal to 7b over b plus c with a d to the side, and we're solving that for b. Well, when you got a number or a variable right next to a fraction like this, you can take whatever you have there and put it up in the numerator. So this becomes 7bd over b plus c. The reason why you can do that is because a number or a variable right next to fraction indicates multiplication. And I could always write this in fraction form by putting d over 1. And then if I multiply the two fractions together, I'd get this right here. Okay, so let's go through our steps. First step, get rid of parentheses, don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. Only have one denominator, b plus c, so that is our LCM. So we'll multiply it times the a, and we'll multiply it times this fraction. The b plus c cancels with that. A times b is ab, a times c is ac, equals 7bd. Step 3. Get everything with the variable we're solving for on one side, everything else on the other side. We're solving for b as in Bill, so I'm going to take this ab and move it to the right side. So I get ac is equal to 7bd minus ab. Step 4. If the variable you're solving for is in two or more terms, factor it out. Well, this is in two terms. So we're going to factor out, we were solving for b, right? Yeah. So we'll factor out a b, and that leaves us 7d minus a. Last step. Divide both sides by what's in front of / back of the variable you're solving for. Solving for b as in Bill. There's nothing in front of it, but there's a 7d minus a after it. So we're going to divide both sides by 7d minus a. So 7d minus a cancels there. And we got b is equal to ac over 7d minus a. And that's our answer. And the end of that section.